So in the previous video, I introduced the idea of intrusion protection systems, or IPSs, and I really talked about how they were an evolution beyond what the traditional firewall used to do. So if you recall, a firewall basically, or a traditional firewall rather, looks only at things like the source address, the IP address, the source IP address, the destination IP address, the port number, and some very basic pieces of information, and makes a determination about whether a particular network packet should be allowed. And a firewall effectively does kind of a block by default. It kind of takes like a whitelist type of model. And that was fine back in the day when the threats were fairly simple. And nowadays that we have more complex threats and threats that have moved up the stack and are targeting things like web application vulnerabilities and things of that nature, it turns out that just being able to block based purely on these higher level network header packet header characteristics is not sufficient, and you actually have to do a lower level inspection of the actual contents of the packets. And that's really the reason behind why people need IPSs. So what I want to do in this video is talk a bit about different categories of IPSs now that we've kind of motivated the need for looking at the actual content. How is that done in practice? So let me kind of draw a picture here. Imagine you've got a network packet, and let's say it's malicious. Okay, and what we'll do is maybe we'll give this packet a clean header, so it's the kind of thing that your typical firewall won't be able to handle. So there's nothing that's bad about the source IP, the destination IP, or the port, but maybe the actual contents of the packet are malicious. So for example, imagine this is a packet that's going over port 80, and that's the port of which most web traffic goes over. So this might look like a typical packet that's emanating from web browser activity. And when this packet is traveling over the network, let's say it's coming to a particular enterprise, and imagine here's the internet, okay, and imagine that there is an enterprise right here, and there's a company here, and there's a system on that company that's going to be receiving. Let me actually draw that system a bit further down. Imagine there's a system right here that is going to be receiving this packet of information and acting upon it. Maybe there's a user of that system, and the user is maybe he's browsing the web, so he's going to a particular website, like he's doing some kind of HTTP traffic, and as a result is expecting to receive this packet of information coming to him. Okay, now there are two modes, kind of two general modes at which an IPS can work, and one is called kind of passive mode, and the other one is called inline mode. So in passive mode, what you might do is you might have a tap, and in that tap, you're basically going to siphon off traffic. So there's a tap over here, and this tap will actually create a copy of the packet for further analysis. And so let's say the packet's going to be analyzed by a device, and this would be a passive IPS that, let's say, is going to be handling the analysis of this packet. Okay, and then the passive IPS is going to effectively create, if it determines that this packet is malicious, it will create an alert. And so let's say there's a management console, and typically an IPS will ship with some type of a management console that will be used to log alerts, and as a result, anybody, let's say a system administrator who's viewing this console, might see that there's this maybe major red flag happening, that there's some type of alert's been triggered as a result of this packet being sent in. Now, obviously, in this mode, because everything is kind of happening separate from the main flow of traffic, and when you're in kind of pure alert mode with a passive IPS, so let's just call it, let me write the word passive here so you can see I'm talking about passive. When you alert, you are not necessarily blocking when you're in passive mode. So the idea is that you're going to continue to allow the traffic to go through. You're just going to send an alert stating that the traffic is potentially malicious. Okay? And if there is, if this thing failed to work for any reason, if there's any malfunction, or if the IPS didn't quite do its job, that would result in there being no alarms whatsoever, but that would be the extent of the repercussions of messing up. Okay, now another mode you can take, and this is a more aggressive mode, is to actually be inline. And so imagine you have your IPS, and this time this would be more of an inline or active IPS, and this time the IPS would actually reside right here on the network itself, and it would examine all the traffic that's going through. Okay, so let's say this packet here would be examined by this IPS. Okay, and if the IPS determined that the packet was in fact malicious, if the active IPS determined that, it would block the packet. The packet would not be allowed to go through. And in addition, there would also be an alert sent. Okay, so there's some type of an alert as well. But there's also, in addition to there being an alert, there's also a blocking mechanism. Okay? So there's actual blocking taking place. The packet is not going to be allowed to go through. Now, obviously, the challenge here is multifold. Obviously, in this case, if you are wrong, if for some reason you think this packet is malicious but it's not, you have now effectively disrupted service. You have actually prevented this packet from doing what it was supposed to do. And then obviously that if you're wrong, that's a bad thing. But if you were right that the packet was indeed malicious, then it's the good thing that you disrupted that service and you prevented the packet from actually getting to that user. Now, on the flip side, the other challenge is that if you are inline and you're receiving all this network traffic, performance becomes a really critical issue. Performance is hypercritical when you are in active mode because if you are looking at every single packet, that will create a potential bottleneck, so you need these devices to be very fast so that there's no perceived bottleneck to the end user and they're getting the benefit of you knowing about this particular threat. Okay? Now, one other variation I do want to point out here is that you can actually have, in addition to having the IPS running at the network level or even at a tap, you can imagine having an IPS running directly on the box itself that would be receiving the traffic. And imagine every endpoint host would have a piece of software running on it that represents the logic of the IPS. And if you have this type of software running, this is known as host-based detection. And the idea here is that in theory, the host itself, the actual endpoint, also can see what traffic is coming into it. And so it has the same view as anybody else in the network. So it would have the same view as this passive tap. And it can also apply logic at this level and make a determination. And so really there are kind of four different categories. And so I kind of mentioned these earlier. You have the notion of host-based. So in other words, the actual IPS residing on the host. Okay, you may also have network-based. And network-based is sort of the more common. When people think about IPS, they typically think about network-based. And you would maybe delineate host-based as a special case, but you would have to actually qualify that you're talking about host-based. When people typically say IPS, they really do mean network-based in practice. Okay, now the other thing is that we talked about kind of passive mode. And in passive mode, you are copying the traffic, you're analyzing, you're alerting, but you're not blocking. And so really what you're doing there is you are not doing so much intrusion prevention, but you're doing intrusion detection. Okay, and so you might hear this term a lot. You're doing intrusion detection as opposed to actual intrusion prevention. You're detecting the attack, but you're not actually stopping it. And if you are in the actual line of traffic and you are blocking, then you are doing actual intrusion prevention. So intrusion prevention, that means you're actually blocking the attack from taking place. Okay, so now as you can imagine, we will have a nice categorization. You have kind of four different, or really two different dimensions to consider, each of which has two attributes. And so as a result, you'll have kind of four different categories of IPS type solutions. And the first category is an HIDS, or a HIDS, which is a host-based intrusion detection system. You may also have a HIPS, which is a host-based intrusion prevention system. And these just mean that you're doing everything on the host. If you have that device working on the network, then you would have what's called a NIDS, or network-based IDS. In other words, this is a device that's on the network. It's detecting malicious stuff, but it may not actually be preventing it or blocking it in any way. You're just purely detecting it at this point. And then finally, you may have what's called a NIPS, which is a network-based IPS, and that means that you're basically on the network and you are actually blocking traffic. And this is, when we talk about IPS, most of the time, unless you qualify further, this is what people typically mean. They really mean a network-based IPS. Okay? And nowadays, now that processing power is improved and techniques for doing intrusion prevention have improved, people are focusing more of their energy on the actual IPS problem where you can actually be in line versus the kind of traditional, passive tap of a HIDS type solution or a NIDS solution. Okay, so nowadays people talk more about just IPSs, and in many ways you can think of the IPS as a successor in the evolutionary scale among security technologies of the traditional IDS, and the HIPS and NIPS are more powerful because they're able to actually block traffic that is malicious.